Hi all, welcome back to the lectures on foundations of quantum mechanics. Today we are going to discuss a simple problem which demonstrates the use of stationary state to find the solution. Okay, so the question is let psi1 and psi2 are stationary state of the system corresponding to energy E1 and E2 respectively. So if the initial state of the system is psi1 of x, then find the wave function and probability density at subsequent time. So here we have only two stationary states. Then a general state, how we can write the general state? So general state can be written as psi of xt, that would be c1, psi1 of x e raised to minus I e1 t by h cross plus c2 psi2 of x e raised to minus I e2 t by h cross. Okay, so this would be the general state. Now in order to find the exact solution, we have to find out what are the values of c1 and c2. Now we already said that the c1 and c2 can be found by using the initial condition. So in this question it is given that the initial state is psi1 of x, so that means the psi of x0 is psi1 of x. So what it actually means? So this means that the c1 must be 1 and c2 must be 0. Okay, so then we can write the psi of xt, the wave function, is simply as psi1 of x e raised to minus I a1 t by h cross. Now what would be the probability density? So the probability density is mod psi of x square, and that would give mod psi1 of x square. Okay, so this is an expected result because the initial state itself is a stationary state. So then there will not be any change in the probability density thereafter. So the only thing is the wave function will have a dynamical phase. So since the initial state is psi1 of x, it's already a stationary state. So after time t, there will be simply a time evolution. There will be some additional phase factor, and there will not be any additional quantities. And the probability density will remain same. The probability density psi of xt square is same as psi of x0 square. There will not be any time dependence for the probability density. So once initially, if the system is in the stationary state, it will remain in the stationary state forever, except in the state only the difference is in the time evolution of the state. There will be an additional dynamical phase, but it will not affect the probability density because the dynamical phase factor will cancel if you take the mod square of that quantity. Okay, now we can explore what will happen if the initial state is a superposed state. Now instead of the initial state as psi1 of x, suppose you consider a situation in which the psi of x0 is a sum of psi1 of x and psi2 of x. So it is a superposition of two stationary states. Then what is our expectation? So will that will there be any time dependence for the probability density or not? We can check. Okay, now again the starting point is the same. So here we can write a general state psi of xt as c1 psi1 of x e raised to minus I e1 t by h cross and c2 e raised to minus I e2 t by h cross in the side of x. Okay. Now what would be psi at x0? It will simply become c1 psi1 of x plus c2 psi2 of x because these two exponential factor will become 1. And it is given that the psi of x0 is sum of psi1 of x and psi2 of x. So this directly implies c1 must be 1 and c2 must be 1. Okay. So that means the general state the general state psi of xt, since c1 is 1, it is simply psi 1 of x e raised to minus I e1 t by h cross, and psi 2 of x e raised to minus I e2 t by h cross. And what would be the probability density? So the probability density psi of xt square, it is psi star of xt times psi of xt. So this become psi 1 star of x e raised to plus I e1 t by h cross plus psi 2 star of x e raised to plus I e2 t by h cross times psi 1 of x e raised to minus I e1 t by h cross and psi 2 of x e raised to minus I e2 t by h cross. So we'll be getting four terms. So the first term is psi 1 star of x into psi 1 of x, that will simply modulus of psi 1 of x square plus, and there will be quantity psi 1 star into psi 2 of x then e raised to I by h cross e1 minus e2 into t plus there will be psi 2 star psi 1 of x e raised to I by h cross e2 minus e1 t plus mod psi 2 of x square. So we can simplify this expression. So the first term can be written as mod psi 1 x square, and second is mod psi 2 of x square, and third and a cross term would come. And here if you look at this expression, we have two terms. One is psi 1 star psi 2 e raised to I by h cross e1 minus e2, and the second term, so this term is basically the complex conjugate of the second term. The third term is the complex conjugate of the second term. So basically it is a sum of one complex term and its complex conjugate. So suppose if z is x plus iy, then its complex conjugate is z minus I, or it will be the sum of these two. So z plus z star would give 2, the real part of x. So therefore this can be written as 2 times psi 1 star of x and psi 2 of x. So what is the real part of this component? So the real part is cos of e1 minus e2 by h cross into t. Okay, so this is mod psi of xt square, and it is very clear that this the probability density now it's a function of time. It is not independent of time. It harmonically varies with time. So mod psi of xt square harmonically varies with time. Okay, so this is one important point, because the the independency of time for the probability density is only for the stationary state. So if the initial state is the superposition of stationary state, then it is not in the stationary state, it is in the superposition, it is in some other state. So in a general state the probability density may depend on time. So okay, so here what may happen is if E1 is E2, if E1 is E2 means the time difference will go. And in other words, E1 is equal to E2. That means the both psi 1 and psi 2 are same. That is, it is in the same initial state, the same stationary state. So if the system is in the stationary state, then it will remain in that state forever. It will not change according to the normal this Schrodinger equation. Whereas if the system is initially in the superposed state of stationary states, then there will be time evolution for the system, and obviously there will be the variation of the probability density with respect to time. Okay, so here we have followed the algebra that we have discussed in the last class. That is, if you know the stationary state, the possible stationary states, then by knowing the initial state of the system, we can find out the coefficients of the general state C1, C2, etc. And from that, we can find out its probability density. And the probability density will remain as a constant if the initial state is stationary state, and if it is in superposed state, or if it is any other general state, then the probability density may also depend on time. Okay, that's all for now. So we'll see in the next class with the another interesting example of infinite square wave. So thanks for watching this video. See you soon.